Hi, I'm Kahil. Welcome to Full Stem Ahead, Long Island. Long Island is home to almost 3 million people. That's more than 17 states in the nation. It takes innovative technology and lots of bright people to provide the energy that keeps our island running. Behind me, PSEG leads the charge to power the gear in your day. But first, let's beam over to a solar farm that's resolving how to mix renewable energy into our electrical grid. We're at the Northeast Solar Energy Research Center at Brookhaven National Laboratory, and I'm here with Bob LaFaro. What's happening at the Northeast Solar Energy Research Center?
Using renewables to power our homes and offices is of great importance today because of the environmental benefits that it has. But there are certain challenges that need to be addressed. As you can see, a day like this, we are generating power, but there are clouds, so the power being produced decreases. Yeah. And when the clouds go away, the power comes back up again. So you get this variability in power generation. For large plants, for example, the Long Island Solar Farm, which generates 32 megawatts. 32 megawatts would be enough power to power maybe 4,500 homes.
Wow.
All of that power, if that starts varying, it could create control problems on the grid itself. So what we try and do here is look at ways to mitigate that problem. For example, by using energy storage devices, where instead of taking the power from the solar array and injecting it directly into the grid, we can take that power and store it in a battery. And then when we need the power, we can extract it from the battery at a rate that meets our needs.
One of the things I always hear about when people talk about solar panels is how efficient they are. Why is that a big deal?
This 900 kilowatt facility takes 3 acres of land. And if you want to generate enough power to power a city, for example, you need hundreds of acres. And one of the problems is that 15% of the energy coming from the sun is actually turned into useful power.
Oh, that's not
the
a
rest
lot.
of it is lost, right?
Yeah.
At CFN, they have a program where they're actually looking at changing the reflectivity of the materials. So if we could improve the amount of energy that goes through the glass instead of being reflected away, we would actually increase the amount of energy that goes into the panels and thus improve their efficiency.
If the solar panel can absorb 100% of sunlight, would we be able to get 100% efficiency?
No, actually that's not possible. It depends on the material that's being used in the cell itself. The most common material is silicon, and silicon absorbs energy at a certain wavelength of the sun's energy. Panels like this can only get up to an efficiency in the 30% range. But one of the things that they're doing in trying to improve panels is you can actually use different materials, and then each material can be engineered to absorb energy from a different range of wavelengths.
What's the maximum efficiency a solar panel could potentially have?
The multi-junction cells in the lab, they've gotten up to 50–60% efficient. Wow. If we could change the efficiency of these panels and make them 4 times more efficient, 3,600 kilowatts would come out of this facility instead of 900.
We're here talking with Kayla. Kayla, what are you focusing on here?
So here at Brookhaven, I am focusing on the challenges that we face with solar power involving energy capture, transmission, and storage.
Are you a student here?
I attend Cornell University. I just finished my first year in the engineering school there, and I'm working at Brookhaven for the summer on this project, yeah.
Are you from New York?
I went to Manhasset High School, and I spend my summers out on Eastern Long Island around here. I was always, a math and science kid, and my mother always steered me towards STEM. I am planning on majoring in mechanical engineering, cool. But I do have a lot of interest in renewables.
Right.
Our planet needs our help, so I'm really excited to be working on this.
Did you think you'd be able to do this kind of research right here on Long Island?
Well, yeah, I used to come to this laboratory all the time during high school. So much is going on here, and I just feel incredibly blessed to have it right in my backyard.
Next, my friend Aleda is going to show you around PSEG in Hicksville. They're the ones that deliver electricity right to your house.
Thank you, Kahil. Hi, I am Aleda. When charging your cell phone or turning on your computer, you expect things to simply work, but it's not so simple. Follow me into PSEG, where some young minds are working hard behind the scenes to keep us plugged in. So tell me, Kyle, what do we do here?
Yeah, we're in the distribution control room in Hicksville, New York. We have a system that monitors switches on the grid. Okay. If there is some sort of fault on the system, it'll give us alarms. And then we have a board up on the wall that will be single customer calls when people, sitting at their house and their lights go out. and those are where the calls come in. I'm a systems engineer. There are electrical engineers, there are mechanical engineers.
Computer engineers, I will assume.
For sure, absolutely. As well as other studies outside of engineering.
Straight from college here? Or?
Straight from college. I went to Binghamton University, studied industrial systems engineering, and I was fortunate to land a good job out of school.
This is very nice.
Yeah. We have these maps posted digitally on the computer, but we also have them physically on our tables. What you'd see on the map with the different green and red circles, those indicate switches. What these allow us to do is sectionalize and break down an outage to minimize the number of customers out. A smart meter will allow us to digitally read it remotely. What's tough too during storm modes is like we get flooded with outage calls. You know, we see this past winter with nor'easters and big hurricanes that come through. Customers don't have to text, they don't have to call the call center anymore. They'll all happen automatic. They would get live updates both for us and for them. They should be able to see right away how quickly their power is coming back on.
I hear you have another colleague of yours that we would like to meet today.
It was really nice meeting you and helping you out.
What do we have on this screen?
It shows us all of our pending jobs. It shows us the location of all of our crews. And it shows us all of the jobs that we have to get to.
What is that?
That actually shows that customer has solar panels. We have this yellow dot here. That customer called in a no power issue.
If there to be a storm here in Long Island, what would you see there? Would you see a lot of dots?
Yes, we would see a ton of yellow dots filling up our screens.
Where did you go to college?
I went to SUNY Old Westbury. I studied finance.
How did you get from finance to here, to engineering?
I took my base skills in math and my love for numbers and arithmetic and things having a right answer, and I turned it into, I guess, a career now with engineering.
So you went to high school in Plainage?
I went to Plainage High School. Yeah, my family's here, my friends here, my job's here. Can't see myself going anywhere else.
My name's Tara. I grew up on Long Island in Seaford. I just graduated from school about 2 years ago now.
Where did you go to college?
I went to school at Clarkson University.
Oh my husband went to Clarkson
No
University.
way, nobody ever knows Clarkson. It's like all the way at the top of New York. It's so tucked away.
Before you were here at PSEG, where were you before?
I worked for Disneyland in California. Something I really learned at Disney was how to make a guest experience the best it can be. At PSEG, I was here for a month and then we had 4 nor'easters. So I was doing a lot of contacting customers. I still have the same things in mind, just answer with a smile. I'm trying to be as positive as possible. So you're just trying to make it a good experience for them.
We are here at the Energy Management Center at Brookhaven National Laboratory. You know, we were at PSEG. They were telling us about using the smart meters. Can you tell us a little bit about that?
The smart meter will be able to record your power usage. It'll date and time stamp it, and your smartphone might even be able to connect to it directly. They'll be able to better manage their own load profile and say, okay, I'm using most of my electric at this time where it might be more expensive as compared to maybe using it at a later time in the day where it's least expensive. Companies also get hit with something called the demand charge, which runs into the thousands of dollars. So these type of meters will also help with demand management, where if you can keep your demand levels low enough, you'll reduce your cost tremendously over the course of months.
That sounds like a career opportunity for our young students in Long Island.
It's exploding now in the energy field because you have new things coming online, renewable energies that have to be managed, and all of this takes computer power, a lot of brain power. You can develop software packages to manage all of this and to look at it. So yeah, there's a lot of opportunities just in the energy sector alone.
As you can see, there's lots of high voltage career opportunities providing energy to Long Island. If you're amped up about the possibilities, visit listemhub.org.